in order to determine the percent yield, we need two pieces of data. We need the actual yield and the theoretical. Now we kind of mentioned that the actual yield is measured. The actual yield would come from lab data. How much did you actually collect? Whereas the theoretical yield is calculated. Well, in the last section, we had the same reaction, and we calculated the theoretical yield of calcium oxide when 24.8 grams of calcium carbonate are heated. It was over here. And we said that it's just stoichiometry. It's just mass to mass stoichiometry. With a certain amount of calcium carbonate, I can use that ratio from the balanced equation to figure out the amount of product formed, the calcium oxide. We calculated 13.9 grams. That's what we should produce. Well, now without being in the lab and without really running this reaction, they have to tell me the amount that was actually produced. So look for key words like this, where they say, what is the percent yield if 13.1 grams of calcium oxide are actually produced? Here, they're just going to have to give me the actual yield because I'm not the one running the experiment. But then all we have to do is divide my actual yield over my theoretical. When this comes out to be less than 100%, then I know that we lost a little bit of product. So we lost about 6% of our product. And so maybe that was through spilling or not cleaning out our beakers well, or maybe we didn't collect all of the solid. This would be like a solid that would be formed in a test tube or something like that. But somehow we're missing about 6% of our product. If we would be over 100% yield, then we said it's contaminated. There's something else that's adding mass. And so here's what everything could look like kind of put together. In 28, we have 50 grams of silicone dioxide heated with an excess of carbon. So I've got extra carbon, but I only have 50 grams of silicone dioxide. And then eventually they tell me that 27.9 grams of silicone carbide are produced. Sometimes they'll even use the word are actually produced. So to calculate the percent yield, I need to know then the theoretical. Eventually I'll have percent yield equals actual, the 27.9 grams of silicone carbide. But I need to know the theoretical, and then we'll multiply by 100 and we are done. So the theoretical is just going to be mass stoichiometry. I've got a certain amount of silicone dioxide, and with that amount I want to know how much product should I expect. So we start with that 50 grams of SiO2. And eventually I see that it's a 1-to-1 ratio in the balanced equation, which I like, but that is not a ratio of grams. So I'm going to have to get this out of grams and into moles. The periodic table will give me the mass of a mole. So we'll add silicone, that's a little over 28, plus 2 oxygen. So maybe we're looking at about 60.09 grams, and that's the mass of 1 mole. After a while, I hope these mole to mole stoichiometry conversions start to click, that there's always a pattern. We always do the same thing. They just take practice. All right, now that I'm in moles, I can cancel moles of the silicone dioxide and convert it to whatever I want. I want to know about the silicone carbide. And I get that it's a 1-to-1 ratio, and that's not really going to change my final math, but it lines up my units, and nothing makes me happier than seeing my units cancel. And finally then, I want this back in grams. So I'll take moles of silicon carbide, and we want grams. The mass will be on the periodic table. So I'll take my silicon plus a carbon. And my mass is maybe about 40.10, and that's for 1 mole. Moles and moles will cancel. And so now if I plug this in, I'm going to get the theoretical yield. 50 divided by 60.09 times 1 divided by 1. That's not going to change anything. But then I'll multiply by 40.1. Awesome. So this is giving me about 33 maybe like 4 grams. That's my theoretical yield. That's the amount that I should produce. That then gets plugged into my percent yield equation. I should have produced 33.4 grams, but I actually only got 27.9. So I'm expecting this to be just a little bit less than 100%, right? Divided by 33.4 times 100. Yeah, so I got about like an 83.5% yield, which again would have meant that we just lost a little bit of our final product.